services to more than 30 bulk waste generators. Through these 30 projects, they are processing 8 tons of waste per day, providing employment to 35 plus people coming from underprivileged and waste worker sector. He has been awarded by United Nations Development Program under Young Changemaker category in the year 2018 and by Agriculture Minister of Haryana for Best Waste Management Practices in 2019. In 2019, he also got selected amongst the 20 finalists in Pan India Social Startup Accelerator Program, curated by Surge Impact Hyderabad. His work has been covered and appreciated by various print, TV, web, and social media platforms and various educational, commercial, and research institutions. So with this, I'd like to invite Mr. Rahul Khera on the dais, and thank you so much for being here.
Thank you, Richa, for the kind introduction, and thank you, CSE, for having me here to share my views. As the topic of this workshop is about the emission of greenhouse gases. So I think we are towards the end of the workshop, and by now we all would have established and agreed that none of the Indian city is doing a excellent job, or an ideal scenario is there in any of the Indian city in terms of waste management. So everyone has a scope of improvement. Today I'm going to talk about city of Gurgaon, that what good city of Gurgaon has done in order to have a better waste management in place, and in order to reduce the carbon emissions which are a resultant of waste management. So city of Gurgaon in 2017, I'll just give you a little background. In 2017, Municipal Corporation of Gurgaon awarded a contract to a concessionaire for centralized waste management. So when I say centralized waste management, everything was to be transported, the entire waste of the city was to be transported to one common, supposedly processing facility. And there it was supposed to be processed using a waste to energy plant. In the contract, there was no clear definition of what was going to happen with the mixed waste, what was going to happen with the organic fraction of the waste. The only thing that was mentioned that it is going to be a magical waste to energy plant, which is going to convert everything into energy. So since 2017, when this contract was awarded to the concessionaire, Municipal Corporation kept on working with the concessionaire in order to make things better. But by end of 2018, they realized that they cannot keep all their eggs in one basket, and better sense prevailed through some advocacy from some civil service societies, some established decentralized model in the city which were already running. And due to that, there was an intervention which was made in 2018. And the municipal commissioner at that time, he introduced a parallel policy saying that, okay, this centralized waste management project will be there. But along with that, there is now a mandate for bulk waste generator to segregate their waste and to do on-site composting of their segregated waste. Along with that, since the conversations were already going on in the environmental circle, in the civil societies, that what should be the right way of processing the waste. So I think towards the end of this workshop, I think we all must have somewhere established that fact that the emissions, when we talk about the emissions, the closer the waste gets processed to the source of generation, lesser the emissions are going to be, whether it be the emissions related to the transport or the processing itself. So working on that model, somewhere the push from the citizens and the civil society was to adapt this model, where we were talking about a decentralized model, where we were talking about that the municipal corporation should first identify the waste generator, categorize the waste generator, and should be having 2 different methods or policies to handle them. So that is when the bulk waste generators were formally identified by Municipal Corporation of Gurgaon, saying that anyone who generates 50 kg or more waste is going to be a bulk waste generator. And there was a process which was rolled out that for the bulk waste generators, there were 3 primary duties. They had to source segregate their waste, they had to process their organic fraction of the waste, and whatever the remaining of the waste was, that was to be given to the concessionaire who was going to run the centralized composting, centralized waste management plant. Along with that, there were suggestions. So whatever is appearing on this slide, this was not what was implemented by Gurgaon. Gurgaon just implemented this highlighted portion through that intervention. But this is what everyone thought will be an ideal scenario, that, okay, if the bulk waste generator is processing their own waste on site, then the dry waste from the bulk waste generator and from the non-bulk waste generator should be sent to some of the material recovery facilities that can be set by the municipal corporation itself or the concessionaire who was going to take care of the centralized waste management plant, or by some private players. But that never saw the day of light. So this was the model. So this was the model that we were trying to propose. Now, one good thing that happened, at least due to that highlighted intervention that was made by MCG, was that it gave a lot of momentum, the initial momentum that was required to at least push this concept of decentralization in the city. I'm not saying that we are at a very good stage, the conversion rate was excellent, but it gave the initial momentum to the initiative. So what municipal corporation did in terms of the enforcement is that the first and the foremost thing is that they defined bulk waste generator. Anyone who is generating more than 50 kg of waste is a bulk waste generator. It was mandatory for them to source segregate. It was mandatory for them to do on-site composting, and the remaining fraction of the waste was to be given to the concessionaire. There were provisions of penalties for the defaulters. And another good thing that the municipal corporation did was providing a provision of empanelment of agencies who can help these bulk waste generator to process their waste within the premises. Because it was a new technology, the bulk waste generators were not ready to take it up themselves. So they empaneled few agencies, 8 to 10 agencies, and said that, okay, these are the people or these are the agencies through whom you can take these solutions and services. In terms of the support to the bulk waste generator for adapting these policy, the bulk waste generators were offered a discount on the collection fees of remaining of the waste. There was a compost buyback policy that was introduced at 5 rupees a kg. And there were certain talks which were going on, but they again never got realized, of allocating green space for the bulk waste generator who did not have enough space, and providing CSR funds. So some of these things were actually realized on ground and some of them did not. So I'm talking about this model because, as I established the fact that the closer the waste will be processed, the lesser the emission will be. Another few good things that happened because of this initial intervention of municipal corporation in 2018 is that there were some more innovative models that started coming, which supported decentralized waste management. Now, biogas technology, we must have, before coming to biogas technology, so the initial momentum that we got through that, we are currently running around 35 projects in Gurgaon, average processing around 10 tons of waste per day. We are employing around 40 people from the waste worker colony who run these various compost plants of ours. And the number of citizens that we are catering through our services is around 40,000 plus. So we are ensuring that by providing these decentralized services, we are able to get segregated waste from these 40,000 citizens. Because when you are working on a decentralized model, there's more accountability, there's more visibility. You can have a better track of the segregation. As many of the speakers said, that segregation is a problem. We do not face that kind of problem when we work on a decentralized model. Another good thing, as I was saying, this happened that there were few good innovative models that came into picture because of this decentralization push. Biogas, we all must have discussed in last couple of days, but a classic problem with the biogas is the use case of biogas in a housing society. Because bulk waste, when we talk about bulk waste generator, housing societies form a chunk of bulk waste generator. But how do you use biogas for bulk waste generators, right? So there's a very interesting model that we have launched in Gurgaon, where it's a distributed biogas system. So at the end of the bulk waste generator, we just install some small equipment that help us to convert the waste into slurry form. And this slurry is stored in a tank. And in a duration of 2 days, 3 days, or 4 days, whenever the slurry needs to be transported, it then gets transported to the main gas generating unit, where the gas is generated, and the gas is used to generate electricity, which is used for the captive use right now. We are working with DHBVN to have a net metering so that the electricity can be supplied and credited back to our electricity bill. So this is an interesting model that has actually opened the space of biogas for the housing societies as well, because otherwise housing societies do not have a use case of having a captive plant entirely there. Other interesting models that happened due to this decentralization push is horticulture waste management. In urban cities, horticulture waste is a big problem. And horticulture waste is a twofold problem. One is the logistics of it. The volume is such and the density of the horticulture waste is such that the transportation cost is huge. And the second is the processing of it. So we have tried to address the first part of it as of now, the logistics part of it. We have started a horticulture waste management as a service. No one wants to put any kind of infrastructure or any kind of capital cost for horticulture. So we have brought in a heavy duty portable shredder. So whenever there is a horticulture waste that has got accumulated at the society's end, we send the shredder reduces the volume by 90% and the transportation becomes efficient. And then the processing can also be seen. Right now we are composting it, but as the volume increases, the discussion can also happen about setting up a briquette or a pallet plant as well. So these are the kind of intervention or the innovative models that got introduced due to the decentralization push. Of course, as I said that no city is doing an idle job here. So Gurgaon also has a lot of challenges. The basic of non-adaptation or not replication of these decentralized model in the pace, in the frequency that it should have been. One of the most important reason is because of the non-availability of the bylaws in Gurgaon. So Gurgaon Municipal Corporation has not notified the bylaws as of now. They have been sending notices, but they have not taken the courage enough to notify the bylaws as of now. Then there are some other operational issues with the bulk waste generator. They don't have space. Some of them don't have funds. So there is a regular conversation that goes on with municipal corporation, with other civil society members who are helping to refine this decentralized policy so that a new notification can be rolled out in coming few months, which addresses all the learnings that we have had from the past. So these are few of the learnings that we had due to which the adoption is slow. So as I was saying, the highlighted in green is something that Gurgaon has implemented. All these are ideal scenarios which we want the city to achieve someday, but these are not yet existing in the city of Gurgaon. So through our 35 projects, what we want to convey here is that, see, we know there are problems, but we have to see at the positive aspect of it. Umeed pe duniya kayam hai, jise kehte hain. So we have to see at the positive side and we have to believe in the small incremental steps that can actually lead to big impact. I'll show you with an example that this was the first project that we started in 2018. It is a society of 500 flats. The project has been sustaining since 2018. So it is 6th year we are running the project successfully. Since 2018, that society has diverted 376,000 kilograms of waste, of organic fraction of waste from going to the landfill. And while doing so, each household of the housing society has kind of reduced their emission, which is equivalent to riding approximately 9,000 kilometers in a car. So that is the kind of impact that has been created by one society. And imagine if this is being done by 35 societies, then what is the incremental impact that we are talking about? So just to give you some context, we are talking about methane emission reduction. So in 2022, our organization's impact report says that we have processed around 2,400 tons of waste, which is equivalent to 4 days of organic fraction of waste that the city of Gurgaon generates. So if we look things into perspective, then as a small organization, we were able to process the waste, which could have gone to the landfill and have emitted methane for next 15 years. So we have reduced that 4 days of waste from the entire city of Gurgaon, which has a population of around 15 lakh. just by doing that decentralized waste management. So imagine that if a right framework, if the right kind of support is provided to organizations who are working on decentralized model, and if these organizations are replicated, then one organization is able to take care of 10 ton per day today. If we are provided the right kind of environment, we can grow 10 times, and 10 such organizations can actually take care of the entire fraction of the waste in the city. So that is the mode that we need to look forward if we are talking about the emission control. The last and the concluding slide is that how do we bring efficiency into decentralized waste management? See, it is going to be effective. There's no rocket science. We all understand that if it is going to be decentralized, it is going to be effective. But there are improvisations that are required in decentralized waste management as well. We have to change the narrative first of all. Right now, the narrative is you are a bulk waste generator, you process your waste. You are a bulk waste generator, you process the waste. So that kind of develops a mindset that, okay, my work is only to process the waste. I don't have to look at the emission part of it. Right. But whereas we have to understand that the entire framework is being designed to control the emissions, to have a positive climate impact. So the narrative also has to change from the end user perspective that whatever technology, whatever processes you are choosing, it has to be a eco-friendly. Like you said in Kerala, you're working on eco-friendly and people-friendly technology. So it has to be an eco-friendly technology. Otherwise, we will see that in name of decentralization, the OWC machines which claim to convert waste into compost in 24 hours, they will fill the vacuum which exists in the market, which is again going to be counterproductive. Another very important aspect of this decentralization is, along with changing the narrative, we have to understand that there has to be a paradigm shift in terms of what kind of organizations are handling the waste in India. See, waste is a very sensitive and a complex subject. You need the right mindset of organization to handle it. I've heard stories from Khandelwal ji. There are scientists on the panel who have shared their experience with the government department. They have shared their experience with the private agencies who have been working. The engineer did not even know that there is a methane reduction that needs to happen. So there has to be a right mindset, for which I think we also need to flourish as a policy. The social enterprises. Right now, social enterprise is just a term that I can use for my enterprise, but there's no legal definition of it. So there are either NGOs or there are core businesses who are working in this field. So a legal framework has to be provided to social enterprises who can work with that mindset to solve this complex social and environmental problem. It cannot happen with the mindset of business, or it cannot happen with the mindset of NGO only, which always depends on external support. It has to be a self-sustaining business model, but where the process and the purpose is also kept at equal importance at the profit. The third important thing is that as a social enterprise, I personally face this challenge, and I'm pretty sure that there are organizations who want to do good work, but we do not have that kind of capability, that kind of capacity to invest into research. Neither we have those kind of talent with us. So here the academies and the research institutes have to really collaborate with the enterprises who are working in waste, so that we can understand the nitty-gritties of emission. Right now, we are also working as a waste management agency. We also have to change our perspective of reducing the emission in our processes. So if decentralized, so let's say if centralized waste management emit X amount of methane, by doing it decentralized, maybe currently my organization or any organization who is working on decentralized model might be able to do it X by 2, the emissions. But I'm sure that there's a potential of reducing it by 2x by 4, where we need research and academia to help us. Technology review and recommendation. As I said, that decentralization is not going to solve all problems unless we review that what kind of technologies are allowed, and whatever technologies are functioning, there has to be a proper monitoring of their emissions as well. So there was a report which was released last week by CSE, where the focus was that whether the decentralized waste management plants are following the FCO standards, right? We never talk about whether the decentralized waste management plants are following the emission standards or not. What is the kind of methane gets generated even if you're composting decentralized manner as well. Methane gets generated. What kind of methane is getting generated there? Is there a scope of reducing it? And I'm pretty sure that there is a scope of reducing it. But that comes with a cost, right? And we have to understand the business aspect here as well, that a bulk waste generator is not opening its arm to spend X amount of money to take care of all these parameters, right? They also look at it as a compliance thing only. So if we really want to have these things incorporated at the process level, that how we can further reduce the methane in the process, then there also has to be intervention by the municipal corporation. We always talk about, so the report said that none of the samples that were collected from Gurgaon were meeting the FCO standards, right? So if we are really bothered about FCO standards, can't we have a model where we always talk about that, okay, either raw waste can go to a central processing facility, or it can go to a clustered processing facility, or it can get processed in a decentralized manner. Why don't we think about a model where the decentralized waste management agencies who are working in a limited space which is provided by bulk waste generator, so they will always have a cycle of 21 days, 30 days, 30 days, 40 days, not more than that. And we all know that compost is like wine. The more you cure it, the better it gets. But we don't have that kind of space and that kind of manpower provided by the bulk waste generator. So can't we have a facility where the decentralized waste management agencies, after a certain phase or after a certain number of days, can actually provide that compost to the city municipal corporation, who can further mature it and bring it to a standard where it can be actually sold as per the policies by the government? Because as a small organization, it is not possible for me to bring that standard to that level. So these kind of innovative models also have to be developed, where city municipal corporation and social enterprises have to collaborate with each other to make this process emission focused, not just waste management focused. So this was my concluding remark. I'll be happy to take any questions afterwards.
Provoking and insightful presentation. We will take the questions after all the, presentations. And I think we are due with two presentations now. So now I would like to call Nikhil Cairo from Goa State Pollution. Sorry, I'm so sorry. Goa Solid Waste Management. How do you call it?
Goa Waste Management Corporation.
Corporation. He just informed me, this you should not call it Goa Municipal Corporation. It's a different organization. Goa Waste Management Corporation. Okay, so we have Nikhil with us. He's a civil engineer. He has completed his MTech in environmental engineering from BITS Pilani, Goa, and presently pursuing his PhD from BITS Pilani, Goa on solid waste management. He has worked with Goa State Pollution Control Board as junior environmental engineer for 4 years, and is currently working from the last 5 years as assistant manager in Goa Waste Management Corporation, which is a unique special purpose vehicle, which is proactively working on the issue of solid waste management in the state of Goa. Welcome, Nikhil.
Thank you. I would like to thank CSE and Richa Madam to giving us this opportunity to present what my state is doing in waste management. So first of all, I would like to tell about the background of my organization, that is Goa Waste Management Corporation. So it is a special purpose vehicle formed for centralized treatment of solid waste. So it comes under the aegis of Department of Science and Technology. So there is an act called as Goa Waste Management Corporation Act of 2016, wherein we were formed. So there were a lot of questions being asked by the previous speakers about what to do with biomethane, why the dump sites are created. So I would say in Goa, we follow a zero dump policy, wherein all the dumps are remediated. And henceforth, what to do with the present waste? The main question arises, what about next? Once you clear the dump, it's not that it's going to be cleared forever. It's going to increase again and again. So what we do in Goa is we treat the waste prior to that. So we have MBT systems, that is mechanical biological treatments, been provided at different stages. Like we have 2 facilities in Goa. So I will be explaining about the facilities. Then there was also one speaker, Secretary Sir Ashish Tiwari sir said, best present technologies available in India for waste management and on PPP model. So in Goa, we follow the PPP model, wherein the land is provided by the government of Goa, and the plant is set up by the concessionaire or the contractor who is appointed the contract. It's a national tenders are floated, and we get in the contractors. Also, the question was asked regarding what can be done on the biomined area or whatever land has been reclaimed already. As you all know, that there's a lot of NIM principle followed across India, not in my backyard principle. So I would suggest that such lands that are reclaimed after remediation should be used for waste management activities, other than used again for dumping of waste within the same site. So coming to my presentation back. So these are there were around 16 sites of dump sites that were existing in Goa. So we have remediated around 11 dump sites across Goa. And we have data of only some sites wherein the already remediated waste has to be transported to the cement factories. So like my counterpart and the speaker, Sir Dilip sir said, that we do Goa doesn't have a incinerator or a cement factory to process this waste. Like sir also has said, a lot of challenges are there. Though we have a good calorific value of around 4,500 kilocalorie joules per kg. So we had to transport it to our neighboring state of Karnataka, which is around 260 kilometers. So we spend a lot of money in transporting this waste from Goa to, that's why it is remaining. So if you see, there is some quantity that is piled up and it is remediated. It's already remediated and it's covered due to monsoon in Goa. And if you see on the left hand side, there are 5 more sites that will be that we have already identified. And once we are done with this, the entire dumps in Goa will be cleared off. And there are no presently active dumping going on. So whatever waste comes in, we have set up these facilities. This is one of the facilities that we have, is an integrated solid waste management facility. It's a 250 TPD plus 20%. So it's a mechanical biological treatment. So the land identified was a existing dump site where we remediated the whole site. It is a brownfield project and we have converted it into, the same site has been converted into a waste management facility. In this is the image of 2014 Google image and the same image of 2022, wherein we have expanded now to 250 TPD solid waste management facility. So coming to the salient features of the facility, it's a 250 TPD plus 20% plant, wherein the entire built-up area is around 18,000 square meters. Till date, the facility has treated around 350,000 tons of waste and generated 2,000 plus units of electricity. And the major plus point is there are less than 3% of the inert every day that goes to the landfill. When I say inert, it is only the residue inert, not any bulk material or recyclable or combustible material. It is only inert that goes into the landfill. 3% that is. Rest all the waste goes to the sanitary land. That's all the waste goes to different components. We segregate the waste into 16 different fractions. And all those fractions are either recyclable or whatever can be recycled is recycled, and the rest goes into the as RDF. Coming to the wet waste, we have 2 biomethane processes followed, wherein the wet waste is converted into electricity. We generate around 30,000 units per day of electricity. So this is the aerial view of the facility, wherein our administrative office is also in the plant itself. So this is the whole facility wherein there is a complete dry line and a wet line. So whatever waste that comes, I would like to stress on one more important point that we follow in Goa is we have source segregation, that is door-to-door collection of waste, which is a must for any facility to function. I would say as you have rightly said, there are a lot of facilities in India which initially started, but over a years it went down because they could not handle the waste that is coming in. We also had similar problems, but we tackled it because we had the source segregation at place. And we stressed upon it. Initially, we used to receive mixed waste, but over the years, we have also expanded it to dry and wet line. This is the aerial view of the facility. The facility operates almost 24 hours. So there is a cleaning shift and all the other things. So coming to the processes followed, mechanism of solid waste management facility, that is material segregation and recovery facility, dry and wet waste fraction processing line, biomethanation and sludge dewatering system, composting line, biogas genset, based power plant, and sanitary landfill. So all these components are included and part of the initial tender itself. So the entire facility was built with all these components into it. So just I'll give you a glimpse of it. This is the dry waste tipping line and the wet waste tipping line. To control the odor in the wet waste line, we have infeed bunkers, which are double door system, wherein the smell there is a lot of smell that comes out during a wet processing. So we have double door system with biofilters. So this captures the fugitive emissions of foul smell is captured within the facility itself. Then coming to the dry line, there is manual sorting and material segregation that happens. 14 different fractions of waste is segregated into recyclable fractions. This data, the entire data of our plant is available on our website. So at the end of the day, I will give you the link to our website wherein you can visit it. Then coming to the biomethanation plant, we have 50 capacity one and 100 TPD capacity one or two biomethanation plants. These biomethanation plants are thermophilic, wherein the heat is supplied, and under anaerobic condition, they generate methane. Methane is then scrubbed to purification, like sulfur and all is removed. We don't remove CO2. Apart from that, is supplied to the CAT engines, which generate electricity. We generate around 30,000 units, of which 15,000 are used in-house, and the remaining 15,000 is supplied to the grid. So there is a net metering per day. Whatever remains, the sludge residue from the biomethanation plant, from in-vessel composting, we put it in the, it is dewatered and it is put in the solar drying beds. So our compost is free from plastic. That's one of the important thing to note down is we don't have any plastic residue in the compost. It has FOC clearances, standards, it's meeting the FOC clearance. We have certification also. Success story of the plant is we have employed the rag pickers who are working on these dump sites. So this was a big dump site. So we have employed all those rag pickers who are working on this dump site. We have given them insurance, EPF, all those things have been employed, and they have been working with us for last 7 years. The plant was operational even during COVID-19. We have school children visiting the facility, both from Goa. There's every day one school that visits, so that to inculcate in the young minds why segregation and source segregation is important. Also, there are international and visits from delegates abroad also. The plant is subjected to NGT scrutiny also. And in fact, they have recommended such plants to be set up in other states also. We have set up another integrated plant, 100 TPD integrated plant in South Goa, which can manage the solid waste. So this is this is whatever fallouts we had in the integrated solid plants in Saligaon has been taken care over here. So this is operational from May 2022. It caters to 4 talukas and generate around 800 megawatts of gas. So the difference between here is we have a bunker system for the dry waste also. And Kakora facility, in Saligaon facility, we had opened on the tipping floor, the waste was dumped, but here we have hopper system for the processing of dry waste. That's the difference. Rest all is the same as Saligaon facility. We have a sanitary landfill also and a solar drying bed. So coming to other facilities, we have also been, GWMC has also been assigned a task to develop other facilities like biomedical waste, CND waste, e-waste, which we are in process. E-waste, we are process of setting up e-waste and a CND waste facility in the state, centralized facility, which is in process. So coming to biomedical waste, which I was part of and as a project in charge. So this has a 300 kg incinerator, which treats the yellow category waste. And as of today, we receive around 300 kgs per day of biomedical waste. That is including all the 4 categories. And till now, we have treated around 1,938 tons of biomedical waste. 1,263 healthcare facilities are registered with this common centralized facility, and 6,578 beds are catered from this facility. So this is the aerial view of the facility, how it looks like. This is the incinerator, which is a rotary incinerator, 300 kgs. So waste is put in from the main initially from a hopper. It is going to a temperature, in the primary chamber, it goes to a temperature of around 800 degrees centigrade. And the secondary chamber, it goes to around 1300 degrees centigrade. From there, it is put in the scrubbing media or APCD, air pollution control device, which is a 7-stage purification system. This is one of the best because we have imported the technology from Germany. There are candle mechanism, ceramic candles being used. So it purifies the air before it is let into the atmosphere. So there are sensors also on this. So once it comes from the secondary chamber of 1,300 degrees, it goes into the cyclone. From the cyclone, it goes into the cooling tower, and which cools down the air to almost 300 to 250 degrees centigrade. and then it goes into the ceramic filters or a bag filter. From the bag filter, it is transported to the air vent. And in case if the system, on the air vent, there are sensors, and the entire operation is put on the PLC SCADA based system. In case if there are any abnormalities or there is a puncture in the ceramic candles, there is a secondary mechanism of wet scrubbing. So that initially starts operation. So coming to the hazardous waste, we have a 25 TPA secured landfill and a 1.5 capacity incinerator, which is operational from 15/5/1/2023. So these are few of the pictures. Coming to the other waste, like this is what is treated at the wet and dry waste, the remaining part wherever it is not getting treated. So the Goa government has set up through Director of Panchayat material recovery facilities within the state at each Panchayat level. So what they do is they do collection of dry waste, dry non-biological waste at these material recovery facilities. And then comes the job of GWMC, wherein we collect this waste from the secondary collection point and we take it to a baling station. It is baled and then sent to cement factories in Karnataka. Around per day, we send around 80 to 100 tons per day of this non-biological dry waste. Also, we do collection from highway cleaning because Goa is a touristic state and we generate around 700 tons per day, 700 to 800 tons per day of waste, of which is treated here. And the remaining balance is all this which comes from the other secondary collection of waste. Coming to the point, sir, as you rightly said, you notified, we also have a Goa Non-Biological Act 1996, which was established in the year 19, wherein we penalize the offender, whoever does the dumping of waste or burning of waste, they are penalized under this act. So the fines were initially 500 and 1,000, so which we have increased now to almost 2,500 to 5,000 to individuals and 50,000 to 1 lakh to commercial establishments. I'll show you a short video of our facility. This is a 10-minute video, so you can.
Goa is a land of immense beauty and as such attracts thousands of tourists every year. But unfortunately, this beauty is not untouched by the mounting waste problems that the world is facing. In order to tackle this problem, our former Chief Minister, Sri Manohar Parrikar, determined to find a scientific solution, set up a team of dedicated individuals, visited and studied both Indian and foreign waste technology facilities to resolve the problem. I extended privilege we associated with waste management plant at Salilong since its inception. Initially, the Department of Science and Technology thereafter, Goa Waste Management Corporation came into being, and thereafter we expanded it, and now the operations are on Hindustan Waste Management Limited, and usually come out of the government of Goa over the Hindustan Waste Management Private Limited, set up a state-of-the-art facility with some of the most advanced technology in waste management. Work commenced under the supervision of an expert committee headed by Padma Shri Dr. Conclave, along with members from NEERI, IIT Mumbai, and its Goa.
EWSC is the only way possibly for treating the solid waste to be generated in our Goa. This is that we can make this free of charges.
An existing landfill was identified as the landfills project. The team began setting up a waste treatment facility while simultaneously remediating the waste from the landfill. In an astonishing 45 days, 50,000 tons was treated in refuse-derived fuel RDF and compost by 2 multi-deck vibratory screens, along with other heavy machinery and carriage vehicles. RDF was sent to cement companies and the compost was used for green belt development. The entire dump was cleared and sanitary landfill cells were constructed on safe land. Construction of the facility continued at a rapid pace, while being closely monitored by experienced engineers to ensure the utmost quality. Also, trained technicians from foreign-based equipment manufacturers assisted in supervision of the machinery installation. After 15 months of dedicated work, India's first integrated solid waste treatment facility was finally operational. The 100 tons per day solid waste management facility, SWMF, Saligamboa, which was put in operations in August of 2016, was subsequently upgraded 250 tons per day in December 2021, for which the financial assistance was available from NABARD.
Initially, Rural Infrastructure Development Fund was started in the year 1996 with an aim to provide loans to state government for completion of incomplete projects related to irrigation, flood protection, and watershed management. The demand for rural infrastructure has undergone over the last few years. Taking cognizance of this transformation, various activities such as solid waste management, which are necessary for holistic and rural development, have been considered in the past. Nowadays, finance further statement that Saligaw under Transit 27.
Facility adopts an integrated treatment process wherein there are segregated lines for treatment of wet and dry waste. The dry waste is brought into the facility by panchayats in trucks and are weighed at the weighing station, and then are unloaded onto the tipping floor. Here, a front loader loads this waste into an in-feed bunker and bag opener, chain conveyor carries it to a wind sifter, which separates the waste into 8 fractions: heavy, medium, and light. Medium fraction, mainly comprising of recyclables, are conveyed to manual sorting station for sorting of recyclables. Waste is sorted into multiple recyclable fractions. These fractions are baled and stored separately before being sent to recyclers. Light fraction is taken to the RDF storage area. RDF is used for co-processing by cement companies to place the coal. A separate wet waste shed is provided to receive the incoming wet waste. Wet waste is loaded to the in-feed bunkers with multiple screw conveyors, which homogenize the content and feed the same into an organic extrusion press. This unit automatically segregates the mixed waste into dry or inorganic fractions and wet or organic fractions. The bulk is then pumped into the thermophilic chest. Here it ferments and generates biogas, which is blended, scrubbed of H2S, and fed into biogas engines of 1,370 kilowatt capacity. The excess biogas is flared over. The generated electricity is utilized to run the entire facility, and the balance is exported to the grid. The rejected sludge is then taken to compressed centrifuge, where the seawater and the seawater solids are then taken into the drying shed for drying and composting. In the solar drying shed, a turning and conveying machine helps to separate the molecule from the sludge, yielding the dry granulated compost, then sent out directly as a fine quality compost. The grit, which is less than 10% of the waste, is disposed into the scientific handle and filled and lined with bentonite, HDPE, and geotextile covers. After it is cleaned, centric and flow wash effluent from solid waste management facility is treated to the HDPE and then equalized to the equalization tank. It is treated biologically in the sequential batch reactor, which will further reduce the pollutant growth in the effluent. It is further treated in multi-grade filters, followed by activated carbon filters, and is disinfected using chlorine. This treated water is stored in treated water storage tanks for gardening and firewater storage tanks for any further use. Biofilters are used to ensure that odorous airs are effectively sucked and absorbed from the process area before it is vented into the atmosphere. Ambient air at the sorting station is always kept clean and cool by using air filters and cooling systems. The complete facility is monitored and operated from the central control room via a PLC SCADA based system. The engineer on watch also has a complete visual contact with key areas of the plant through scenes or cameras. The facility is also fully equipped with necessary safety features, including fully fledged firefighting. In just a span of 7 years, the facility has managed to treat 3.35 lakh metric tons of solid waste and generate 2.31 crore kilowatt-hours of power.
The same after the one official best biomass of waste plants generated in an average of 28,000 units per year. With 40% used in the facility operation and the rest is completely irrelevant. The TWMP announced the Department of Science, Technology and Waste Management is committed to sustainable development in waste management and proud of the progress made.
From physical change to facility surroundings is an added bonus.
The proud feeling of the individual, owing the scientific students who are coming their review of this plant, just to see the facility, 250 degree mixed waste, they are getting per day, to this mixed waste, they are generating the power. One of the best practice the colleges management is going on at this plant.
With most materials being recycled or repurposed, and only a small fraction ending up in the landfill, sufficient electricity to run the entire facility is being generated by biogas and from the solar panels installed. Any excess is exported to the local grid. Water being recycled for maintenance and non-potable use, and practicing rainwater harvesting, along with the high quality compost that is sent out. City is clearly the plans of vision of a single waste for a self-sustainable and clean power. TWMC is committed to sustainable waste management practices that will benefit the environment and the people of Goa generations to come.
You can visit our website on this QR link which I have shared. And any questions, I'm open for questions.
Thank you so much, Nikhil, for sharing the success story of Goa state through Goa Waste Management
you.
Corporation efforts. Now, I would like to call our speaker, Mr. Vivek Ojha, to talk about legacy waste management and how it can be used as a mitigation strategy for methane reduction. Mr. Vivek Ojha has over 12 years of wide experience in environmental domain through execution of more than 10 solid waste management projects. After completion of his master's in environmental science and technology from Banaras Hindu University, he has explored this subject under the roof of CSIR, National Environmental Engineering Research Institute, Nagpur. Further, he served Ramki, RQ's Spark in different roles and capacities. Currently, Mr. Ojha is working as a waste management specialist with different projects developer to assist them to carry out feasibility studies, site survey, DPR preparations, formulation of monitoring and execution plans for waste management project. Welcome, Vivek, sir. Over to you.
Good afternoon, all of you. Myself, Vivek Ojha. Thank you, CSE, for giving me opportunity to present this potential strategy to reduce methane emissions by processing of legacy waste. If you see the 2021 report of Central Pollution Control Board, the total generations per day of solid waste is approx 1.6 lakh metric ton. With considering the collection efficiency of 95%, we are able to collect 1.5 lakh metric ton. Out of 1.5 lakh metric ton, we are able to treat 79,000. We are doing landfill of around 29,000, and unaccounted means we are not able to retrieve where the waste is going on. So this is the data of Central Pollution Control Board. If you consider that the treatment is 50%, but practically, I think it's not possible. 50%, 5% maybe. So the potential of legacy waste, if you add the treatment, landfill, and the unaccounted waste, it will become around 100%. It means there is no processing is going on. As per the data, I'm not claiming anyone. The fresh waste processing is not going on. All the fresh waste is being converted into the legacy waste. So Again, as per the Data of Swachh Bharat Mission, September 2019, their dashboard, the total dump sites, identified dump sites who have legacy waste is around 2,300. But as per my knowledge, the total ULB is around 4,800 something. So out of 4,800, 2,303 dump site has been identified with the legacy waste. And if you see the total deposited legacy waste, 2,313 lakh metric ton. If you see the total area, it around 20,000 acres, 21,000 acres, out of which we have achieved around 36% at 29 lakh metric ton. But still the so is going on for 1,500 lakh metric ton of legacy waste. And we have to clear around 17,000 of area, which has been contaminated with the legacy waste. So overall, right now, what we have achieved, 100% remediations of 327 dumping sites, around 426 lakh metric ton we have processed, and we have cleared around 2,352 acres of land. So, but still we have to do a lot of things for the legacy waste. Why the legacy waste has been accumulated on the dumping sites? If you see the scenario of the Indian collection, transportations, and the entire waste management practices, the waste is getting generated from different streams like residential areas, hotels, markets, wholesale markets. This means the bulk waste generator, slaughterhouse. It comes under the community bin, or we can do direct door-to-door collections through the variety of transportation vehicles. And finally, it getting disposed of in the low-lying areas. I'm talking about the centralized facilities. There are a lot of decentralized facilities. Initiative has been taken, but still, if you consider the accountability of centralized systems, so we could not say that the segregation is going on. So what happens? There is no recycling. There is no any resource recovery is happening. And finally, the wet organic waste, it's not processed. We are not able to process it through the composting or biomethanations because of the segregation. Segregation is the main issue, because if you install any technology, the technocrats say, if you provide me that segregated waste, then only it will be feasible and it will be viable. If you are not providing me the segregated waste, then definitely I will not take care of your waste. So segregation is an issue. Without segregations, it's very difficult to achieve the recycling as well as the processing of the wet waste. But if you see the justifications, like, is it justified? If you are disposing unscientifically waste, it causes anaerobic degradations. Anaerobic degradations basically generate the landfill gas. And the second one thing, it produces leachate. Leachate contaminate the nearby environment, and the landfill gas it basically contribute in the greenhouse gas emissions through the contribute in global warming through the greenhouse emissions. So overall, if you see the loss of energy and loss of resources, we can record. Why the methane is generating from solid waste? Because solid waste, when we're talking about the solid waste, there are two parts. One is wet and one is dry. Whenever the conditions of anaerobic conditions prevail, the methane will generate. So methane is basically responsible for one of greenhouse gases, and its potential is 21 times higher than the CO2. So it's very, it's not eco-friendly. The second one thing, if wet waste degraded, about 60% of biogas, whatever you can say the LFG, landfill gas also, is producing. And if you are not trapping it, if you are not using it, finally it goes to the environment, it will harm the environment, and it causes the global warming. Overall, GHG emissions, 16% is the 60% is basically the responsibility comes under the methane, and after that the carbon dioxide comes. Out of 16%, if you see the anthropogenic methane emissions, there are natural as well as the anthropogenic. In anthropogenic conditions, solid waste is basically accountable for 14%. There are also other streams also, like the rice cultivations, manure, gas systems. But today, since we are talking about the solid waste, legacy waste, so legacy waste is basically accountable for 14% of the methane emissions. For better understanding of the methane scenario, how the methane is being generated in the landfill, I will not talk about the quantitative the data and all the things. I will share my experiences. So for sharing the experiences, I am using one of the case study for the Agra Nagar Nigam. Agra Nagar Nigam is basically, they have total 100 wards. Area is around 121 square kilometer. And the population, if you consider the floating populations, it will comes around 30 lakhs. In 2023, the average waste generations on the annual basis, it's around 1100. The entire waste of Agra Nagar Nigam, there are some decentralized facility, but the efficiency is not good. So most of the waste is coming on the dumping sites, Kuberpur dumping sites. It's a designated dumping sites of Agra Nagar Nigam, which is very closer to river Yamuna. It's around 110 kilometers. The project boundary is around 10 kilometers. 110 meters from the river Yamuna. The total area is sprawl over an area. The total area is sprawl around 72 acres. Out of 72 acres, the 42 acres was basically the footprint area for the legacy waste, which was the defined project area. And this dumping site was being used for since 2011. The total generation was 1100. The site has recorded 9.40 lakh metric ton. So Agra Nagar Nigam has taken initiative to process the entire legacy waste through the bioremediations and biomining process. So when we talk about the bioremediations and biomining process, as per the CPCB, basically the three concepts comes under this CPCB norms. The first one is we have to segregate according to the solid waste management rule, which is as per the clause ZJ, JK of the rule 15 of schedule 1. The second one is whatever the byproducts is being produced through this segregations, you have to transport or you have to use there scientifically. And the third one is it should be in the compliances of SWM rule 2016, plastic waste management rule 2016, and other applicable regulatory and judicial guidelines. For the for some research purpose, I have carried out one physical characterizations. Since the Agra dumping site has achieved a height of around 15 meters. So on different strata, I have carried out the physical characterizations. If you see the layer 1, in layer 1, we have recorded some undegradable wet waste, but in layer 2, you will not find because almost it degraded and it converts into the some shape, some texture. You will not find in layer 3 also the same conditions and the averages. Very interesting that C&D amount we have recorded around about 43%. Inert, it means the bio-earth, basically. It comes under the form of inert. Inert, I'm not saying the inert means the residual organic part, but inert, since we have not categorized it, so that's why we have put in the inert. So around 13%. The same thing has been presented in the pie chart. This is the steps we have followed for the processing of our legacy waste. The first one is basically we have demarcated an area. Based on the demarcated of area, we have planned this will be our phase 1, phase 2, and phase 3 because the total area was 42 acres. After that, we have identified from where we have to start because this site is active and we are receiving the fresh waste also. So there should be a parcel of land allocated for the fresh waste, and once its allocations has been done, then only we can start our legacy waste processing. So after the demarcations, we first do the loosening of legacy waste, excavation of legacy waste. Then there are 5 different methods as suggested by Central Pollution Control Board: thin layer, cone layer, triangle, thin layer, the cone method, window method, trailer method. There are 5 different stabilizations method. Out of 5 window formations we have considered because we have adequate parcel of land and our quantity is huge. So we have considered window formations. And after window formations, since we are talking about the legacy waste, so there were some organic fractions. So we have added some inoculum to degrade the organic fractions present in the legacy waste, and we have turned it. Because after the turning, the aeration will happen and finally it will degrade and the moisture content will also reduce. Overall, our purpose is to segregate the legacy waste. So if the moisture content will be in the legacy waste, we cannot separate it. So moisture content is not a good parameter for us. If high moisture content, we are unable to segregate it. So we regularly turn it, and the purpose of turning was basically the sun dry. So we done sun dry, and after the sun dry, we have to check the stabilization. Stabilization, it means if the organic content is there, so definitely we could not achieve the moisture content of 18% or 60%, which is our desirable amount. So through seed germination method, we basically check in, there is one in-house laboratory. So we do the seed germination test. Through seed germination test, we check whether the organic fraction is still remain on the legacy waste or not. If it's remain, then we could not segregate it because it will not meet our requirement. It will not be segregated. So once we say, no, this seed germination test has been approved, now we will transport the sterilized waste to the different trommel sites, and finally the segregation will happen through this trommel machine. We faced problem because this project was commenced in 2018 August. At that time, there was no guideline for the biomining. So we faced some problem because Agra is one of the very sensitive issues in terms of legal and judicial things. Regular NGT visit just because of Taj Mahal, regular pollution control board, central pollution control board, state pollution control board, NGT visit happens. So it was a challenging task for us. What should be our methodology? How we should move ahead, because there was no any guideline how we have to do the biomining. So based on the discussion, verbal discussion with Central Pollution Control Board, we have decided that we will install three sets of trommel machines. If you see the Central Pollution Control Board rules, they are also doing advocacy about the segregations in three parts. One is large objects through the sizes of 150. And the second one is basically 18 mm trommel size. And the third one is 8 mm sizes. But overall, the concept is you have to separate based on the size. You are not going to separate on the basis of density. So based on the size, so we have used 125 mm trommel, then 35 ml, and again the 8 mm. So we use three sets of trommels to separate our stabilized waste. If you see this picture, there's one air blower because the moisture content sometimes, because weather is not in our hand. So sometimes moisture content is high. So the impact of moisture content will not be absorbed in the RDF, but it will be affect our segregations of last part, like 8 mm sizes, which contains the bio-earth. So it contains of organic materials also. So it get stick on the trommel. So we use some air venting system so that the moisture content will be less and our efficiency will be higher. So these are the four byproducts: 125 mm, 6 mm, 35 mm, and -6 mm. 125 mm basically the large objects, then 35 basically the plastics, plus 6 mm inert and the small things, -6 mm basically the bio-earth, or we can say that it's a soil enricher materials we are obtaining after the segregations. Since my topic is related to methane, so if you see the entire process of the legacy waste, what we are doing, first one is we are excavating. Interventions we have made, losing of deposited legacy waste. Once you excavate the waste, definitely the anaerobic conditions will not prevail. So you are providing aerations. So mitigations of methane we are doing. Window formations. Again, we are basically, whatever the systems we have followed, we are basically deprived from the anaerobic conditions. We are moving towards the aerobic conditions. So overall window formations, it will be exposed through the airflow. Then again, the mitigations of method, addition of inoculum, it will degrade the organic fractions. So methane will be mitigated. Routine turning, it will increase the free air space and it will provide the oxygen for the aerobic conditions. Then again, the mitigations of measures. Seed germination test, it will basically the quality for the quality monitoring. The third one is transportation, since we are transporting only the stabilized waste. So again, the mitigations of methane and whatever the byproducts we are producing like RDF, it should not contain any organic parts. And we are basically separating through the trommel. So organic part will be not in our RDF. So again, we are avoiding the methane formations. C&D, definitely it's inert material. So we are not expecting any methane formation. Inert, it's completely non-reactive things. But in inert, if you see the 35 mm to 6 mm, there are some organic content maybe. But since the texture of the inert is different, and there are different sizes, so the free air space will be in the inert part. So we are not expecting any anaerobic conditions. The final one is bio-earth. Bio-earth is basically the organic part, and we can say not an organic part, but it constitutes about 5 to 7% of organic part. So we are not going for any anaerobic conditions. So overall, it's we are avoiding the formation of methane. So this is how the methane is basically we are mitigating through the legacy waste process. Everyone is saying, no. In legacy waste, you are just separating 4 parts, but we are doing the same thing which should happen in the initial stage. In initial stage, we are not segregating. So in the final stage, we are segregating. And once you segregate the waste, whether in the first stage or last stage, it will not contaminate the environment, because you are separating the organic part. We are separating the RDF, because the impact of solid waste land dumping sites or solid waste unprocessed solid waste comes when it comes under it's a very complex biochemical process. But if you are separating, then you are avoiding the biochemical process. So automatically the contaminations and the impact on environment will be lesser than the accumulation of due to accumulation of the legacy waste. Factors for methane formations: age of landfill. Age of landfill is also one of the important parameters, because each organic component have their own life, and there are different bacteria like mesophilic, thermophilic bacteria are working on it. So as we all know, I think yesterday already professor and scientists have explained, there are 4 different phases: hydrolysis, acidogenesis, acidogenesis, and then methanogenesis process is required for the formation of methane. So when we're talking about the age, so because landfill have a heterogeneous type of material, so someone will degrade in 1 month, someone will degrade in 2 months, someone will degrade in 6 months. So age is also a factor for the formation of methane. Weather of the city: if the moisture content will be high, definitely the transportations of organic in the second layer will be more. So the weather is also playing a role. The third one is quantification of deposited waste. Quantification of deposited waste, it means if you see because I have handled 2 or 3 sites. So one site in Agra, we have handled 9.4 lakhs. In one site in Kolkata, Bolpur, I have handled around 60,000. In one site of Kolkata, I have handled 1 lakh ton. In Manipur, I have handled around 1.5 lakhs. So what I have observed, quantifications, it means how much quantity has been deposited. It's also play a major role, because the surface area, it will directly exposure to the atmosphere. So it will not create the anaerobic conditions. The angle of exposure, it will directly airflow will receive. So it will not create the anaerobic conditions. So methane will not form. But when, if you are talking about the 15-meter height, so there will be a layer of systems. You have accumulated a lot of organic fractions. So during the winter seasons, during the rainy seasons, basically, when it receives the precipitations, the organic fractions will be settled, and it will create the anaerobic conditions in the second layer, because first layer is being exposed through the surface, but second layer, it is not being exposed through atmosphere. So anaerobic conditions will prevail, and with the free air space, it will basically emit from the surface. Composition, definitely physical and chemical compositions is it's a crucial parameters. In physical compositions, density and compactions. When we're talking about the Indian dumping sites, we are not going to achieve the 1500 densities. Our density is around 600, 650, 750, or in most practices we have to achieve 1200. Texture of waste, after the degradation, the texture of waste changes. Cover material, what type of cover material we are using? According to cover material, also the surface exposure we can restrict. We cannot permit the aeration. Waste layering, how the layer, because in Indian scenario, first we have to dispose of the inert, then organic fractions, then whatever the mixed waste is coming, we are disposing on the top. So waste layering is also one of the factors. Waste is In chemical compositions for the formation of methane, organic content, definitely it's a raw material for the anaerobic conditions, moisture content, carbon to nitrogen ratio, and the pH level. This is basically 3 or 4 critical parameters I have considered. Height of dumping sites, as I told you, height of dumping sites is basically responsible for angle of exposure from the atmosphere, the degradations, the layer degradations, creation of anoxic environment. So overall, if you see, the height of dumping site could be one of the parameter for the anaerobic conditions. Management of dumping sites. We are since our dumping site is not scientific or not engineered land dumping sites, so we are managing it in our way according to the local scenario. As per my experience in Agra or other cities, if you are generating more than 300 TPD waste, so the management of dumping site is differ from the waste generating below 300. In 300 dumping sites, we have to take care of the more than 300 TPD per day. You have to take care of the fleet management. We have to take care of the safety issues, because there are a lot of accident happens. The truck get transferred, and the safety issues are there. Fire is one of the most critical things. So dumping of management of dumping sites, we should minimize the waste at the dumping sites. But right now, all the waste are coming on the dumping site. Waste segregation at source, or suppose if it gets segregated at source, it should be transported separately. In some places in Agra also, I observed it's being separated, but when we're talking about the transportations, they are mixing the wet and dry. Sell out, transfer the waste system to relevant stakeholders. Landfill design, permit the disposal of inerts only, because in some dumping sites, we have a sanitary landfill sites, but initially we have disposed of the residual inert, but after that we have filled it with the mixed waste. So we should permit only the residual inerts. Landfill gas collections and recovery facilities should be there. As per the Solid Waste Management Rule 2016, the exposure level of methane should not exceed 25 LEL. But accumulations because of waste piles, anaerobic zones, organic contamination definitely when we're talking about the mixed waste, uncovered or unmanaged waste. And the second thing, site-specific conditions. Every city have their own characteristics of waste. So I think we should make a plan. We should make a plan based on the site characteristics, based on the cities. As per my field observations, basically if you divide the entire dumping site in 3 different layers, the first layer is basically the emission point of methane, but mid layer and the last layer is basically responsible for the creating the methane, because of the organic content and anaerobic environment, because we are regularly dumping, and there are very compactions. Compaction is not we are achieving the 1500, but at least we are achieving 1200 or 1100. So mid and last layer is responsible for the methane accumulations. Composition as well as the site-specific conditions we should consider for each city. Signs of methane gas emissions. One is order. Gas bubbles. Gas bubbles, if you see any unscientific dumping sites, basically during the rainy seasons, they create a pond. They create a pond which basically utilized for the storing of water during the rainy seasons, and it will use during the fire. If any fire occurs, they use this pond, whatever the water accumulated in the pond, they use for the to mitigate the fire mitigations measures. Soil gas concentration, lab subsidence. This is all the impact of the methane. How we should monitor the surface? How should we monitor the methane? One is surface emission monitoring, identification of biomethane potential or site surveys, frequently turning off waste, and seed germination test. Seed germination test is basically recommended by the Central Pollution Control Board. These all are the impacts: contribution in climate change, air quality, order. Conclusion: legacy waste. Definitely, someone is saying no, legacy waste is nothing, but we are separating, but it's play a crucial role in the reduction of methane. We should rehabilitate our old dump sites. If it's caps, then definitely there should be some gas excavation system. Implement recommended management practices to designing and operating landfills to effective capture of the landfill gas. Comprehensive emissions monitoring and landfill site and organics should be monitored. And the second one thing, on the daily basis we should monitor. At least we should provide one gas venting system, because there is no any gas venting system on the unscientific landfill sites. So we are not able to monitor how much methane is getting produced, how much CO2 is getting produced. So at least there should be one venting system. Prevent and reduce the organic waste. These all are basically related to diversion of the organic waste. Organic waste as well as the dry material also. Regulatory compliances and enforcement play a crucial role, because without penalty and these things, we could not be a responsible person to manage the waste in a scientific manner. Sustainable legacy waste practices we should adopt. And the third and most important thing, what I have observed during my 4 or 5 years of experiences, we should monitoring the methane as well as the non-methane organic compounds like VOCs, because we are inhaling it. VOCs, it's a hidden, I think we have not explored so much. So VOC is one of the critical parameters or critical emissions we observe on the dumping sites. So this is all about it.
Thank you, Vivek sir. Now we will open this. Thanks to all the speakers, first of all. And now if I may request all the speakers to come and take their chairs so that we can start the Q&A session. May I please invite Shri Anil Agrawal? Sorry, Anil Agnihotri sir, Dr. Anil Agnihotri sir, Shri Dilip Kumar Madhavan, Pradeep Kumar Khandelwal, Rahul Khera, Vivek Oja, and Nikhil. Yes, I'll just get one from you. So I'd like to start with the question that came from you, sir. So it was about NH, National Highway Authority of India. What are the tests? No, because I think this is going to be an interesting discussion, which we all would like to hear. So if you could throw some light on what are the quality parameters and how did you get it verified by the PRI?
See, the first we did a study on the legacy waste in 2009. Depending upon that study, we found that the inert coming out from the legacy waste is useful for embankment filling or filling in the low-lying area. On the basis of that report, we went to NHI and we showed that report to NHI. NHI agreed subject to recommendation from CRRI. NHI given the study to CRRI to do the study for inert waste. CRRI took 200 metric tons of waste. 200 metric tons of waste from my Gazipur landfill site, taking at different levels and tested for all parameters. They have submitted the report to NHI with the recommendations that this waste, processed legacy waste can be used for Meerut Expressway. That was in 2016. After that, NHI and MCD and signed an MOU that we will work together on the basis that NHI will utilize all this waste. NHI then floated the tender in early 2017. to use all this legacy, process this legacy waste and use for Meerut Expressway. Somehow, due to some accommodations and some other have told NHAI that this cannot be used. Whereas CRRI has recommended, I will not name the professor, one of the IIT Delhi professor, which still tease me by saying that this is Mr. Khandelwal who can eat away all his legacy waste. Like that, he teased me in all the workshops and other forums. But I have no, when I explained them that this is the process and this is the process, by this way we can do this. So he not agreed. The only reason he said that if you pass this inert weight through a water, your water color will change. And with this analogy, he might have told to NHI or some other people that there's a discussion started. Whether we use it or not use it, where to use it. We did lot of efforts and finally NHI did the tender, then postponed the date. We requested even Supreme Court, NGT, PMO. I have 4 minutes of PMO to direct NHI to use this, at least for the pilot. Even at least for the pilot, they have not done. Then again, question has started, DLP, defect liability, who will own the defect liability period, defect liability, who will own the cost. Again, initially it was decided the cost will be borne by the NHI. But after that, what second thought has come? So the pilot has not been taken up. And the CRRI report, which I will share to everybody, is clearly says is suitable for embankment fill.
Yeah, so the brown coloration happens because of the presence of organic matter. And in civil engineering, that is a complete no, because if you add organics into cement matrix or anything like that, it will retard the hydration process. Maybe that could be the reason, I don't know. But if you're going to use it for embankments or for road constructions and things like that, I don't think this is going to be that much hazardous or impactful. I'm not sure because I have no.
So if you see the quality of soil required for the embankment filling, permits 8 to 10% of organic.
Yes, for that purpose, it is. I think it
So,
can be
and
used.
that in my testing of inert, it was within that limit.
Okay. So what's happening now? I mean, I think the inerts which are recovered is going to NHAI approved site. No?
Now, present status is this. At that time, the lot of transportation can be saved, the entire material can be used, that thing. Now we are sending, now NHAI agreed to use this inert, but at a distance around above 50 kilometers. Like we are sending to Faridabad, we are sending to Vallabhgarh, we are sending to this in UP Bagpat and all those areas. So this is the issue.
How can this be justified that a waste on this Meerut highway cannot be used and it can be used 50 kilometers away from that?
That only NHAI can answer you.
I can answer that doubt about it, because they don't want any controversy, anything happening, it goes wrong, then it will go to the national NCR region. So they may be highlighted. That may be the reason they are avoiding 50 kilometers radius.
No, sir, there was no such reason, because now they are using in even expressway. And within NCR. The Faridabad is NCR, the Vallabhgarh is in NCR, the Dehradun expressway is in NCR. I don't know, the 4 secretaries, 2 secretary of Government of India, 2 IS officer of local body and NHAI have signed that MOU. And that MOU is available on the record. Is not is my property as anybody's property. What will you do? I am telling you, there are 28 corrigendum issued for tender. And you will be surprised to know the fact of Meerut Expressway. If anybody is living towards Ghaziabad or this thing has gone at that time to Ghaziabad or other things, lot of solid waste lying on the roadside has been buried in the expressway. Throughout the Ghaziabad. And I have a pictures of that photo, this thing, 3,344 meters of municipal solid waste lying there. And they buried, they have not taken it out.
Thank you, sir. Now moving to the next question. So there was one question yesterday we were discussing about the moisture content of legacy waste. I would like to know it from Vivek Oja sir and rest of the panelists. What is the typical moisture content in legacy waste? I mean, I'm talking about mixed legacy waste.
It's around 25%.
25%.
Raw material.
Like how old that waste should be, like if I will say that, because I think that should be the optimum moisture content for, good methane generation should be 38.8%. So if it is below that, the yield will be less, but there will be methane generation. Sir, Agnihotri sir, if you don't.
Yes, you are very right. The more moisture, the more methane gas. It depends on the how much organic content is being dumped on the waste dump site. And if you look particularly Delhi and Mumbai, the huge amount of organic waste is going on the top of it. So what happens in the upper layer, there is a very intense aerobic activity. When the aerobic activity up to 1 meter, there's a lot of water is produced. So whatever is evaporated, more than that water is produced there. And during the middle and last layer, there is a huge amount of water produced in situ through various processes of the anaerobic digestion below 1, 2 meters, 3 meters. So because that is the region we get the continuous leachate flowing from the all landfill sites. So moisture is what he's talking 25, it is almost, this is the upper layer we can talk where the methane generation is not taking place. I am talking of the region, anaerobic region, when the redox potential is minus 250 millivolt to minus 300 millivolt. So plus region, there is not much moisture, whatever the aerobic decomposition, there is a lot of water produced. I can cite in very simple, anybody can test this because I have a very small mandir at my home and I have a dustbin, covered dustbin. I put every day whatever the flowers I remove from the idols, and you will not believe after every Sunday I clean it myself. When I keep rotating the flowers, after 3 or 4 days, I get lot of leachate in that small dustbin. So that you can see how this anybody can test it. So the moisture, you are very right for the good methane production, and we are really getting good methane all dump sites. That's my.
So if I may not be wrong if I say that Indian landfills are generating a lot of methane because we have ideal condition for decomposition of waste. Now, I'm not saying from that perspective that we should start doing something to extract methane. No, that's not the idea. The idea is the landfills are actually the real source of methane, and we need to get rid of the landfills. I mean, I'm talking about the open dump sites. Yeah. So you have to add something.
Yeah, because landfills are the big source of methane extraction. And that is why we got a study done in 2008. And that report says is enough.
Yeah, but sir, the issue is with the fact that somebody is going to use this data to, have a facility which is promoting the idea of biocapping and extracting methane out of it. And Agnihotri sir, I would like you to talk about the integrity of landfill, the Indian dump sites, why it is not a feasible solution, technically feasible solution to extract methane gas from Indian dump sites.
As for the technology is concerned, there is no dearth of technology. Only the problem is the quantum of amount of money required for doing the geotextile lining. Instead, just putting a plastic, it is not going to
Economical violence.
It's the economical viability, not the technical viability.
No. I'm not coming to economics because it's a very-
Both of you pitch in for this.
I have to say something, what he's talking, because I am telling you, I have seen the rolling land, I've seen Gazipur, both sides were very poorly lined. So if you look at the global scenario, I have seen the Pointe Hill landfill size, which is producing 50 megawatts of power. And that too in the environmental condition where the temperature goes to 3 degrees centigrade, which is not good for the reactor, but they are producing 50 megawatts for the last 40 years. Similarly, Beverly Hills, which is the most costly place in the world, they are producing 38 megawatts of power. And you will be surprised, of late they have covered the landfill and they have put up a huge solar plant. So they are getting power from the top and power from the bottom. So, but we don't have, since we have no landfills to dumps, we can not do that. What are the best we can do? We can completely, because the biomining has limitations. The huge, like Devna, you see the Gorei, you see the Gajipura Bhavan, huge. So whatever the best you can do, as if you have money, money is the biggest constraint, and the technology providers, because Indian contractors cannot do that because they have never done it. International contractors, when we are collaborating, but so many fields for the international companies, why can't we do for the waste management? That's what.
Sir, do you have to add something? Khandewal sir.
I do not agree that only international agencies can do it. When we started solid waste management in 2005, we invited international agencies. 2-3 international agencies are working in Delhi, but the output and the progress or the impact is almost same as what Indian parties are doing it.
Thank you, sir.
So, add
So
something.
please also let us also invite questions from others. I think you already had asked your question. Just go ahead and ask it, but then we'll also move to others. Yeah.
Okay. One question I have from Nikhil. So Nikhil, in Goa, other than the municipal solid waste problem for the Goans, you also have the problem of solid waste on the beach side, right? So don't you think it's a big challenge in Goa? How do you people are handling that problem?
So we have, as I said, highway cleaning was one of the things. We have a lot of tourist influx. So because of which we have an equal number of populations, around 15 lakhs tourist population, which we have to tackle with. And to tackle the garbage problem related to that, we have beach cleaning as well as highway cleaning contractors put in place. So they do the collection from the beaches as well as the highways, and it is brought to these centralized facilities. So we treat this waste from the beach as well as the highway cleaning on these in this centralized facilities. Coming to your point, a specific point where when we say beach waste, it has soil contamination in it. So we use a cyclone separator to segregate the soil before it is put in the system to treat further on. We remove the soil because soil has a major impact on our biodigesters.
Yeah, that's a bigger challenge. And one more thing I would like to add about yesterday, and still since we are talking about methane generation potential, I guess students and audience are also a bit confused about the methane generation potential. It is like how much we can produce in ideal condition. That is the thing. It's not about how much we are producing. That is the different thing, right? Thank you.
Models are estimating how much we can produce, and which is misleading for the policymakers because they think that now we will extract methane from landfills. So we said that is why we don't know what are these input parameters and from where we are getting that input parameters and all of that. Do we have the text?
Thank you. My question is from Dilip sir. In your presentation, you mentioned about your collaboration with CREDAI. So, and it's really strange to see like an organization like CREDAI having a collaboration in a state like Kerala, which, you know, they both are on a different spectrum. So would you just give a reflection that how organizations like CREDAI are useful in sort of a public-private participation, if there is any?
Good. We are promoting decentralized mode of waste treatment. In flats, we know that space is the main constraints. The CREDAI, the Builders Association, they have taken an initiative to establish source level treatment for flats. There is a system for providing technical support for flat association to establish source level treatment at their rooftop for treating biodegradable waste. CREDAI is only standing behind. Some agencies are enlisted by CREDAI for giving that support. There is a system of bio-bin, providing system of bio-bin. The Haritha Karma Sena, like Kudumbasri volunteers, they are collecting waste from each household, taking to the top of the flats. They are doing the composting process at the top. The compost produced from that part they are utilizing in their compound for gardening. Remaining they are pulling together in a centralized facility and marketing in another SHG group, Kudumbasri group. In that way, it is happening.
Any further question from the participants? Okay.
My question is to Nikhil. I'm Dr. Gopakumar, Health Officer, Trivandrum Corporation. My question is, how do you manage your slaughter waste in your integrated facility? Because my question got a lot of angles. Please understand it.
Yes. So as I said, this facility is for integrated solid waste management from the municipal waste, that is door-to-door collection. Slaughter waste do a separate collection and it is treated at a separate facility. Slaughter rendering facility is required for treatment of slaughtering waste. So we don't accept slaughter waste over here at this facility. So we have a separate rendering process which requires to treat the slaughter waste. That is the bones and the other things, feathers and all the things. Yeah. So we have a separate facility which is coming up for treatment of slaughter waste. We can't mix slaughter waste with municipal solid waste. It becomes a lot of problems. So.
Yes, that's why, because no one had touched that organic part, because especially in South,
yes,
the main problem is more meat lovers. So we have more meat slaughter waste.
This facility can tackle cooked food, cooked waste, not the raw meat. The bones and all are not accepted at this facility. We do the checking. It is done. The waste comes in, it is screened for any contaminants of unwanted things like biomedical waste, e-waste or hazardous waste, and then it is sent to the respective facilities.
Yeah, because according to me, Trivandrum Corporation is having a waste of 480 tons per day. And around 20 to 30 tons of waste, chicken slaughter waste itself is there. It is collected through our system and it is going to a rendering plant. It is converted to protein powder, which is added to animal feeds. And these plants, can you imagine there is 500 tons of such waste is processed in Kerala per day?
Yes.
500 tons of slaughter waste is processed per day. There is now it is 63 plants are there. Some plants are having 100-ton capacity also. Small plants also there, 2 to 4-ton plants also there.
Right.
So nobody had talked about converting these materials into value-added things. That is my point, because Richa, while Dr. Richa presented, she had on her slide, the first part was we can use it in cattle feed, animal husbandry, but no one had touched that part after that, because it is a value-added product which make this waste highly
more methane generation
yes.
from this waste.
Thank
yes.
you.
Case study, sir, and we will I'll connect with you to cover this, because I did not get any successful case study when I was talking about, because it was a pre-landfill phase methane reduction strategy, which no one talked about. And thank you for sharing your.
Which, for slaughterhouse waste, Delhi has already planned and tendered for processing this slaughterhouse waste for methane generation. Yeah, sponge waste.
My next question is for Rahul ji. So how much methane we can produce by treating 1 ton of biodegradable waste? And this biodegradable waste is mixed of everything. I mean, it could be greens and kitchen waste, a typical waste that you are getting in Gurugram.
Right. So see, when we are treating waste in a decentralized fashion, so if you're talking about the methane generation through a biogas plant, so for every ton of waste, the biogas generation potential is around 80 to 100 meter cube. This is what we are achieving at one of our plant that we have established in Gurgaon. Depending upon the feed of the waste, if the feed of the waste is cooked food waste from restaurant, hotels, then the produce can be increased. But if it is raw waste, which is the leftover, which is the peels of vegetables and all that, then the produce can further reduce to 70 or 65.
Can I say it is 75?
80 to 100, 80 to 100 is achievable using the latest technology, biogas plants, 80 to 100 is achievable.
So can I also say that if I'm diverting 1 ton of my organic waste from reaching the dump sites,
Right.
that much methane I'm actually saving to get
That's right.
escape into the environment.
That's right.
So I feel this is, yes, sir.
Yeah. In the way 2004-5, just after passing my IIT, MTech from IIT, I did one study for CDM project, how much methane can be generated from the fresh waste. Keeping at that time, the generation was 6,000 tons per day, out of which we have taken 3,000 tons per day as a organic content. And there was one equation on the basis of that.
Dulong equation.
Yeah. So I have calculated and put up the proposal for CDM project at that time.
The Dulong equation, Deval? Yeah.
I think you go through the reports by the DD. So they have reported for a typical Indian municipal solid waste with this much moisture, this much organic content. They reported about say 200 cubic meters of per ton. But the question is that what you are intending, I remove 1 ton of what he's talking, that 80 to 100, but you forget about the transition period from which period to which period the waste has taken the time, gestation period to get to the treatment side. You lose a lot of methane gas during the process.
Yeah, but I was just thinking that we can use it as a proxy to say that, you know, this much methane.
So
No, but
Rather go with the findings, which is, you know, happening, methane generation happening on ground rather than estimates.
because this waste that we are receiving at these plant is coming to the plant within 24 hours of generation of waste. So it is not taking a lot of time and losing its methane generating potential anyway.
Yeah.
So what we designed the latest plants in our this thing, Mr. Pant can explain much better than me. He 5 TBD plant can generate 500 cubic meters of methane, which can be converted to 250 megawatt, 250 kilowatt of the power. This is what, on the basis of that model, we put up this 10 plants of 5 TBD.
Sir, and that reminds me of 200 TPD composting plant, and it is listed under a
CDM project. That
So
was in 2007.
What is the status of that plant now, sir? I mean,
Uh,
it's not working, but it is still, I can see that in the CDM list. I mean, one of the
Yeah.
projects under.
Yeah, at that time we listed it and now that plant we are converting into the CNG plant.
Okay, thank
Under
you.
renovation. That plant
Okay.
is under renovation.
So maybe we can just take 2 more questions and we.
My question is to Rahul actually, and Dilip sir can also add into it. So what's the challenge in scaling up the decentralized treatment? I think you have covered it, but have you looked at, is there a limit to how much we can treat through decentralized treatment? Yeah.
Right. See, I think for any city or any municipal corporation, it has to be a multi-layer approach. It can never be just the decentralized or the centralized. It has to be multi-layer because of the kind of waste that we receive, kind of the waste generator we have in the city. CSE presented a report last week where they have kind of come to a number that from bulk waste generators, around 40 to 50% waste gets generated. So at least for these bulk waste generator, the strategy has to be decentralized. Now, if we talk about specific challenges that comes in converting these bulk waste generator to adapt the decentralized policy, it is a multi-level challenge, right? The genuine challenges from the bulk waste generator side is the space, because the policy has come in 2016 and the societies are there since 1900s, right? So we have to acknowledge and accept that there are some genuine challenges in terms of space where the technology and the models have to be innovative to address those challenges. So as solid waste management rules also give us a leverage that process the waste as far as possible. So there have to be some innovative offsite models that have to be introduced and encouraged. And there has to be certain policies around those offsite models so that the bulk waste generator can only opt for those models if it is really a genuine need. There has to be a financial deterrent that if they are processing the waste within their premises, then there has to be certain benefits that has to be provided to the bulk waste generator. And if they are going for an offsite model, then okay, you can go for that offsite model, but there has to be certain financial implications for that.
I have different opinion for that. The decentralized waste management have 4 administrative issues. First is willingness. Second is accountability. Third is reconciliation. And fourth and important is NIMMI. Whenever you want to put any decentralized facilities in all the urban areas where all the area has already been developed, you cannot put even a single facility of either 500 kg per day or 5 ton per day. Whatever I put in my this 20-30 facilities, that is on my already existing transfer stations. You can say waste storage depots.
Khandelwalji,
I will not allow 3 times.
Khandelwalji, just sorry for the interruption. Let us not see everything through the lenses of Delhi, right? I have great respect for whatever you have done. Let me just come in, because the question was actually asked to Rahul. There's a complete state. I'm talking about the state of Odisha. There was an order from the office of the chief secretary that the entire state was directed to shut down all centralized contracts. There are 114 ULBs. If I talk in terms of the number of decentralized units, that would be more than 3,000 across the state. The entire state, I'm not saying they are doing brilliant. And these states also includes cities like Bhubaneswar and Cuttack. I understand Delhi's situation is very different, but let's not debate whether decentralized approach is a possibility or it is difficult. We haven't even tried to, move towards decentralization despite knowing the benefit of it. So
Challenges.
no, sir, challenges are different. Sir, challenges are not common challenges, sir. Every city has their own challenges, right?
Challenges.
Maybe, I respectfully differ from that observation.
The next question, and this is going to be the last question.
Last question, and then we have to wrap
Close
up.
the
Yeah.
session.
Please use the mic. Because we have virtual
It's not
participants as well. Yeah.
Sir, as per the solid waste management rule, 5 ton we can process in the decentralized manner, because if you are exceeding the 5 tons, then it will be, you have to take site authorization.
Yeah.
And site
Consent
authorizations, if you go for the pollution control board, then there are a lot of legal provisions. You have to submit the annual report, you have to submit the accident. There are 6 forms in solid waste management rules. So you have to do compliances of all the forms. So I think decentralized facility, as per the government norms, it's less than 5 tons.
Can I add in Tirunelveli Municipal Corporation, generating nearly 400 TPD. They are laying on source level as well as decentralized mode of treatment. There is no centralized facility. It is true that it is not sufficient. That is why we are trying for the centralized one, not treating the whole quantity of waste, only a part. part can be managed at the source level and at the decentralized level. For the last 10 years, there is no centralized facility. Still, they are managing. Health officer of that TMC is here. He can tell that we are able to achieve the result with all these three: source, decentralized, as well as centralized. We are having the gap we are trying to fill up. We know that source level and decentralized facility is not enough. We need to promote the three. Unlike Delhi, we are able to achieve the result through the decentralized as well as source level treatment. In our case, 50% of the waste generator is at household level, nearly 50%. If we are able to achieve 50%, efficiency may not be at 100%. Some quantity has to be handled at the centralized facility. We are calculating the efficiency of treatment at household level as 60%. Remaining 40% has to be handled at a centralized facility. Then only we can achieve the centralized facility in a sustainable, environment-friendly manner. Thank you.
Okay, so all right, a very quick question, right? We are really short of time. Yeah.
Firstly, I just wanted to say it seems so promising how Goa and Kerala has been for a viewing from the perspective of learners. So when it comes to challenges, we talk about technicalities in economics. So we already touched upon technicalities. Now I really want to hear from Nikhil sir and Dilip sir about if you had calculated, like before all of these, bringing this implementation onto ground, how it was randomly being dumped and everything, towards after all of these, obviously it's a huge investment for all the facilities and everything. So I want to know about your economical report about, is it being profitable or it's still on this edge of it? Like it's still economically not that feasible, but we are trying our best.
I would say waste management is not always economical. It depends on the type of waste and the category of what recyclables you will get. In a system like Goa, we have primary collection, which is done by the either the municipality or the village panchayat, where there are contractors appointed to do door-to-door collection. They take out all the recyclables which is there in the waste and they sell it off for their profit. That the revenue is given to the village panchayat or the municipality. When the waste it comes to the processing facility like this, the profit, the margin is from the recyclables. They hardly get any bare recyclables. As rightly said by my colleague from Kerala, the waste, there is a way of decentralization and centralized facility, 50-50%. I would say you can handle the dry waste or the non-biodegradable waste at the decentralized facilities and the biodegradable waste at the centralized facilities, because it becomes very uneconomical to handle the non-biodegradable waste at these facilities because of the robust mechanism involved, the type of and the smell also generated. So it is not so easy to have an APCD for a decentralized facility the way we can have it in a centralized facility. The cost involved is much more. So I would say you can have a centralized facility for the wet waste generation, not for the dry waste. Dry waste can be handled at a decentralized level. It can be bailed off and sent to a recycling facility and anything like that.
I'm so sorry to interrupt. Can we say that Goa is having a sustainable solid waste management system?
Yes, I can say that.
In terms of, I mean,
waste management.
economically and environmentally. And
yes.
Okay. That is the answer. Thanks.
But I think I would like to add one point here. Having said all that, I think Anil Agnihotri sir raised a very valid point when he was speaking there at the podium, that we have all kind of incentives in this country, but waste management, it's very good that we can build up models which are self-sustainable. But if there are any viability gaps, then the government and the corporate through CSR have to be more open to fund these things. Government is getting a lot of fund for emission control. So ultimately we are achieving emission control through it. So I think a government and the corporates have to be more open to invest in waste management projects, because I have kind of tried to pitch waste management projects for CSR, and they are very, very wary of investing into CSR, into waste management project through their CSR funds. So that mindset also needs to change.
Yeah, just wanted to add one part, Richa, is with respect to the economics, as you said, the Goa model is a PPP model wherein 75% of the investment is done by the government and 25% is from the company or the contractor. So that's how we have done, so that the contractor has some burden on his this thing, and there are regular checks done to meet those certain parameters in the tender document itself. There are monthly monitoring reports, or there's a monthly monitoring committee that inspects this plant for those compliances. Apart from the CPCB or State Pollution Control Board or the other norms like EC and all the other clearances, there's a monitoring committee set up by the state government which monitors these parameters, which are set in the tender itself. That's why we are able to run this plant for last 7 years.
What is the rate of return of the capital?
It is-
One question, because it's an environmental cost,
Yes, sir.
which the state has to bear. That is why I mentioned these projects are negative pricing projects. So somebody has to invest money on that.
I think solid waste is being governed by the DST now.
Yes.
It's not by urban development department.
Okay.
So they have good scientific people. They have, because there is need of institutional strengthening.
I think-
Well,
It serves your purpose or not?
In Kerala, people are participating in waste management. They are giving user fee. They are maintaining the SKS, not paid by the government. They are voluntary organizations, especially weaker section of women. They are the SKS people. People are giving user fee. If they are not giving user fee, they have to pay along with their tax. Government made an amendment in Kerala Municipality Act and made it compulsory that people have to pay user fee. If they are not paying, they have to pay along with their building tax. That is the situation. That's why people are contributing, people are participating. At the same time, government is investing money. Government is having some financial constraints. That is why government is taking loan from World Bank. 2,400 crore amount is drawing from World Bank, investing in source level, decentralized and centralized facilities.
So,
That is
so it's the same thing in Goa also, where we have already notified the rates for waste collection through municipality and the panchayat level. DMA and the DOP have already notified garbage tax. What will be the garbage tax for them? So it's already been notified. It's already in process. It's already done.
well, I now have to close it because we are almost an hour over the schedule. Thank you for the nice question. Just a quick point. In CSC, basically, this is how we learn, right? When we meet colleagues from all over the country, when we travel globally, we have a huge global program which Dr. Richa leads. I have never seen a single city having made any attempt to estimate how much are we spending on our waste management operation. So that estimation come in many different forms. Say I have X number of population and expenditure is Y, so I can have a expenditure per head. I can have an expenditure per ton. Unless you do that expenditure, you won't be able to tell even if your waste management is centralized or decentralized. You won't be able to compare whether, I mean, forget about profit. What percentage of the expenditure is being recovered? Now we are using terms like waste to wealth, right? Now we are using term like recovery. But, you know, let us understand that it is a very complex ecosystem. There is no one solution to all waste problems. I would just conclude with one note that waste management is a shared responsibility that begins with the generator. It's a very fundamental principle of the approach to waste management, which probably we haven't been able to realize, or even if the realization is there, it's very, very limited, right? And that is why the traditional approach, the approach is still continuing, and forgive me with great respect to all the esteemed panelists, the focus has been very heavily inclined towards technology. We have been looking for all our waste solution in technologies without realizing that the technology is as good as the people that we are governing, right? I'll give you a classic example. We have Dilip sir here. There was a time, I don't know whether the status is still maintained, almost half of Trivandrum's population were practicing home composting, right? If you monetize it, I'm talking about 150,000 to 200,000 households, because Trivandrum is supposedly having close to 500,000 households in the capital city, right? So imagine if the number is even 100,000, we can come up with a rough estimation of how much of waste is getting treated at source. And if you think it from a different perspective, if these were not being treated at source, the municipal corporation had to mobilize their fleet and their people to collect them. We made a rough estimation of how much the municipal authority would have spent had the waste not been treated at home through home composting. And they ran massive behavior change campaign, the green protocol, my waste, my responsibility, right? And I had the fortune of meeting very senior colleagues in Suchitwa mission, because the way Swachh Bharat mission is implemented in the rest of India is very different from how Kerala does it. In Kerala, Suchitwa mission is just a technical advisory to the department that governs the urban local bodies. So if you quantify, if you monetize that investment on behavior change, which has resulted in so many households doing home composting, they even provided subsidy. We have a very small biodigester, which basically was inspired by the Kerala model. It's nothing but a water tank re-engineered to be a biodigester. We use it in our kitchen, right? We produce enough gas to make tea for almost everyone. That way we save a lot of LPG as well. So I'm coming back to the context. If you monetize, Kerala is saving almost 70 to 80 crore a year by having this waste treated at source. And remember, this is forever. They will never require to lift that waste because it is now embedded into their habit, in their behavior. And that's very important. Like bad behavior, good behavior also takes time to kind of. So when the technology and inclusive approach, investing on changing human behavior, how we behave to waste, right? We are getting more and more wealthy and we are producing more and more waste. I was connected by one colleague from Mumbai, and I was looking at a mind-boggling data that this super rich in Mumbai, the average waste generation per day per person is nearly 3 kilo. So there is so much difference. So I think this entire national conclave, and thanks to Dr. Richa for all the efforts in bringing out the report as well as organizing this huge event and having so many great minds here talking about this agenda. It is now time. Methane could be a proxy indicator to understand how much of waste we have been able to divert from the landfill. And I would request all the esteemed panelists and the keynote speakers who had to leave so that we can come up with some recommendation, which we will then, summarize, and we will then reach out to the people so that it gets some place in the policy and some sort of actions are initiated by Government of India, which probably is currently missing now. So on this note, let me thank all the participants for your time and your participation in this event. Let me thank all the colleagues who have connected us through Twitter, LinkedIn, Facebook, Zoom, and other social media platforms. And my sincerest apology to the virtual participants for not having been able to take much of a question. But I would request Dr. Richa and my other colleagues to consider as many questions that if we can take, and we can communicate them back with whichever way possible. My sincere thanks to our entire unit that deals with solid waste management and circular economy, colleagues in AATI for the great hospitality, Lakhinder for the AV support, and of course, all the esteemed panelists who, despite their very busy schedule, they found time, they realized that it is an agenda that needs the attention. So thank you all very much. I'm sure we will continue to stay with the agenda. It is not just about methane, like Dr. Richa mentioned. I spoke about the SBM agenda. SBM is now mandating every city will have to divert 80% of their current generation by 2026. It's a mission. So mission always comes with a target. Even if it appears that we may not be able to achieve it by 2026, let us achieve it by 2030, 2036, not a problem. But we must make a beginning. That is very, very important. So on that note, thanks to all the esteemed panelists, participants virtually who are present over here. Thank you so much. Till we meet again, take care and stay safe.